Good morning, good afternoon, and good evening, everyone. I am Jacques Fluet, the Data Center Program Director at TIA. I would like to welcome you to today's webinar about the TIA-942 Data Center Standard and Certification for a 5G World.
Please note that any product or services identified or identifiable via a trade name or otherwise in this presentation as a product supplied by a particular supplier is provided for the convenience of users of this presentation and does not constitute an endorsement of any kind by TIA and the product name named. This information may be provided as an example of suitable product available commercially. Equivalent product may be used if they can be shown to lead to the same results. TIA does not endorse any of the company's products or services identifiable in this presentation and does not engage in company or product endorsements.
It is now my pleasure to welcome our speakers for today. First is Jonathan Ju. Jonathan is the president of J&M Consultant, an information technology and telecommunications consulting firm that specializes in data center projects. Jonathan has over 35 years of experience with over 100 data center relocation and infrastructure projects totaling over 2 million square feet of computer room floor space. He is internationally recognized as an expert in data center communications, telecommunications infrastructure, and telecommunications administration. He is a regular speaker at various industry events and has authored and contributed to over 20 magazine articles. He has leadership positions in several U.S. national and international standards committee and is a major contributor to TIA and Dixie. Next, you will hear from Edward Van Lent, Chairman and CEO of the EPI Group of Companies. Edward has over 30 years of experience in the global high-tech and high availability and mission-critical data center industry. With the unique combination of in-depth technical knowledge and an excellent grasp of the trends and developments in the industry, Edward is a key driver behind the success of EPI, growing EPI from a small UK origin company to becoming a global organization with presence in over 60 countries. Edward is an active member of a number of data center professional groups and also sits on the TR42 committee that is responsible for the TIA-942 standard. He has performed hundreds of data center audits worldwide. He has also been honored with multiple awards throughout his career. He is also a regular speaker at industry events on topics related to mission-critical data centers. And the final speaker will be Jim Henry. Jim is the Global Data Center Compliance Manager at Iron Mountain Data Centers and leads the division's enterprise information security, environmental health and safety, and energy management compliance programs. Jim is primarily responsible for global compliance management and information security governance, but also leads the overall program management and development of various data center standards across the organization, spanning the US, Europe, and Asia. Jim has been with Iron Mountain since 2016, holding various roles within the compliance department, and is a certified information systems auditor accredited by Information Systems Audit and Control Association. He is a subject matter expert in various technical and regulatory standards, including TIA-942. And I am Jacques Fluet, Data Center Program Director at TIA and host of this webinar. Now let's take a look at the agenda for today. I will be doing a brief introduction. Then Jonathan Ju will be providing an overview of the TIA-942 standard. Edward Van Lent will be providing an overview of the certification program related to TIA-942. And then we will get a data center operator's perspective from Jim Henry from Iron Mountain and finish with the Q&A. TIA has evolved over the years. We are now structured around four main groups. There's the technology enablement programs that include smart buildings and edge data centers, the government affairs that interfaces with the government and advocates for ICT manufacturers and suppliers, both in the US and internationally, advanced policy position on a wide range of issues, and everything impacting the ICT industry globally. We have a very big standards department, which is ANSI accredited, and it has handled over 3,600 standards and technical documents over the years. And this is driven by over 1,000 volunteers from over 20 countries. Then last but not least, the Quest Forum community that owns the TIA-942 quality management system. They're also involved in developing new standards around supply chain security, and they also are involved in sustainability assessment and benchmarking. We cannot really start a presentation without some numbers. Here are a few of them that show that the data center industry is a growing component of many of the services that we rely on every day. The overall data center capacity is growing. Okay, it has been growing for the last 10 years, and it's expected to continue growing for the next 10. The infrastructure spending is also growing, reaching $200 billion in 2021. It is estimated that there is around 7 million data centers of all sizes in the world, with more being built every day to support the estimated 75 billion connected devices by 2025. The data center industry is driven by the digitalization of the world enabled by the new communications technology. A big driver of this growth is 5G and the new generation of networks. New functionality brought by 5G are opening all kinds of new possibilities. Software-defined network function. 5G has been designed and continue being designed as a software-defined network, starting with the core and now moving into the transport and the access portions of the network. Local breakout or control and user plane separation enable the edge functionality by connecting the applications directly at the edge without having to go back to the core. This enables all kinds of new applications related to the massive IoT and the ultra-reliable low-latency communications. They were not possible before. Think about advanced driver assistance systems and automated vehicles, telemedicine and assisted surgery, online gaming, smart factories, smart buildings, and all kinds of new services based on augmented and virtual reality. All of these applications are enabled by a dynamically orchestrated network slices that will divide the network into logical slices with different performance characteristics required by the different type of service. We're now starting to talk about a minimum guaranteed performance by service in the network. The data centers are the foundation on which these new services are implemented. They have to adapt to the new requirements of the networks, being deployed closer to the end users with a renewed focus on even higher reliability. This leads to a wide variety of types of data center. I've had a few examples here from big hyperscale and co-location sites to much smaller containerized version and even on-premises micro data centers. The next presenters will talk more about how the TIA-942 standard can help with the design and implementation of reliable data centers. Now, Jonathan, the floor is yours.
So TIA-942 is at its core a telecommunications infrastructure standard for data centers, and then we've built a lot of things on top of that. So the half of you that are engineers and consultants will find this very useful. It's the US and Canadian national standard for data center telecom infrastructure, but it's really widely used outside the US as well. I've evaluated and worked on designs for many data centers around the world, and TIA-942 is used for the design of those data centers. TIA-942 is at its core a data center cabling infrastructure standard, and then, as I mentioned, we have a lot of things built up on top of that. On the data center cabling portion, we provide information regarding the type of cables and connectors that are supported, the cabling lengths, and the topology. So you can see a sample topology of a data center, of a sort of a medium-sized data center on the right-hand side of the slide. And then we have, of course, the spaces that you put the telecom infrastructure in. And so we would have requirements for the data center and the distribution spaces inside the data center, like the main distributor, the intermediate, and the horizontal distributor. The main distribution area would be what some people call the MDF in their data center. We also have requirements for the computer rooms, the entrance rooms, some of the support spaces. The type of the requirements that you have for the spaces would include things like the door sizes, the lighting, the temperature, the floor loading requirements, and humidity. We also cover subjects such as cabinets and racks and floor tile cuts. And then, of course, in data centers, we have to cover things like pathways, which are cable trays, conduits, optical fiber duct, and other types of pathways that are supporting the data center. We also just provide guidelines in the data center standard for how to design redundancy in the cabling and the pathways for various levels of redundancy or ratings of the data center. So you can see an example on the right-hand side of the type of redundancy that you might require. So for a rated 2 data center, I would have a redundant entrance room. For a rated 3 data center, I would have redundant pathways, but only one of each of the horizontal distribution area or the main distribution area, for example. But the 2 routes would be redundant. And then for a rated 4 data center, I would have each of the server cabinets, which we call EDAs or equipment distribution areas in the data center standard, connected to 2 horizontal distribution areas or HDAs, and then they would be separated from each other, and there would be diverse routing all the way to diverse MDAs. We have information, a lot of supplemental information in the TI-942 standard. There's a whole section on how to deal with your access providers or carriers, planning the demarcation points with them, coordinating them regarding the type of information they require, like the number of cabinets, how you should be terminating with them, the type of cabling that you require for them. We also provide guidance regarding the length of circuits in data centers, such as T1, E3, T3 type circuits in your data center. We have another section regarding the length of serial console cables in the data center. We have an addendum in the data center standard regarding how to design telecom cabling infrastructure for data center fabrics. This leaf spine architecture, which is now very common, was originally considered to be challenging for data center infrastructure standards. One of the switch manufacturers mentioned to the director of standards in TIA that he didn't think that TI-942 would apply to data center fabrics, so we took that on as a challenge and developed an addendum for how you support data center fabrics using structured cabling. And there's several types of data center fabric designs, including fully mesh and this leaf spine architecture, and we provide guidance on how to support the various mesh or fabric designs with structured cabling. We have a section on energy efficiency, which is now very important. And Edward will be going into this in much more detail, but we have a data center rating system. It's a 4-level rating system, with one having the lowest level of availability and security, and the rated 4 data center having the most availability and security. And these, the criteria for the evaluation in this rating system are divided into 4 areas: telecommunications, electrical, architectural, and mechanical. We're working currently on an addendum T2 to TI-942 addressing the subject of edge data centers, and we hope to finish that work in 2021. We have our first committee ballot going on currently, and we'll be voting on resolving that the comments to that addendum in February. So now I'll turn over the presentation to Edward, who will discuss data center certification. Edward?
Thank you very much, Jonathan, and welcome everybody to today's presentation. It's my pleasure to talk about the TIA certification. you a very quick idea on who EPI is. We basically are a global company with 11 offices around the world, operating in the data center industry for over 30 years. And we are providing data center design and facility certification based on TIA-942, as well as data center governance, operations, and maintenance certification based on DCUS and accredited data center and IT training. Now, one of the key reasons why data center operator owners often choose to go for TIA-942 is because the TIA-942 is truly the only complete data center standard addressing all the aspects of a mission-critical data center. Some guidelines in the market often only address electrical and mechanical systems, which are, of course, important, but for a truly mission-critical data center site, one has to also address other aspects like site location, architectural aspects, physical security, of course, the electrical mechanical systems, telecom infrastructure, very important nowadays, fire safety, monitoring of the facility, and as Jonathan also indicated, efficiency. So data centers which are certified for the conformity to the TIA-942 therefore really stand out if they have been assessed basically on all the aspects which could potentially pose a risk on the availability of the data center. TIA understands that not every data center is equal in terms of business criticality. So therefore the standard has 4 distinct levels for redundancy planning for the data center design and implementation. Rated 1 represents the lowest availability expectation level, which is basically based on a single path of distribution for the electrical, mechanical, and telecommunication infrastructure. This doesn't mean it's a bad data center, but it's just aimed at non-critical environments. Rated 2 has an improved availability expectation where we have a single distribution path still, but we now will add additional components. So, for example, we add an additional UPS, an additional chiller, air conditioner, etc. So this allows you for some level of equipment maintenance and potentially even some component failure. However, there is still a requirement for maintenance, if you have that, then or a failure in the distribution path, then you could still experience downtime. Hence, although it is more robust than a rated 1, it's still often not good enough for truly mission-critical data centers. So that's where rated 3 and rated 4 are aimed at, which is at those environments where high availability is required. Rated 3 is what is defined as a concurrent maintainable data center. This means that this data center can undergo any form of planned maintenance without causing any impact on the IT. Therefore, this supports, of course, 24/7 business operation. This is achieved by having at least one active path and a standby path, which could be activated during those maintenance situations. Please note that there is still a potential unexpected failure in the component and distribution paths, which could lead to downtime. However, most data center operator owners, they still design well above the rated 3 requirement, where they choose to, for example, implement multiple active paths instead of the minimum requirement of one active and one standby. Although, strictly speaking, it's not required from a certification perspective, it is still a very common practice in the industry. Rated 4 is the highest level of redundancy planning. Rated 4 is what is designed and called a fault-tolerant data center. This means that the data center is able to tolerate a single fault on any component, equipment, or part of the distribution path without causing IT downtime. Now, please note that if you are very unlucky and have multiple faults at a single point of time, then you could still potentially be exposed to downtime. So as such, every organization needs to make sure that they still have appropriate business continuity plans in place. Currently, there are 3 types of TIA-942 audit and certifications available in the market. The first one is the design document certification. This is often used by those organizations embarking on a new data center design and build project, or where the data center is undergoing some level of redesign or extension. The principle is that the design documents will be validated against the requirements of the TIA-942 standard. If all is appropriate, then a design certificate for conformity will be awarded. After this, the construction phase typically starts. And the data center operator and owner can, of course, be confident that if all is implemented as per the design, that the data center facilities will then meet the requirement of the standard. Quite a few data center operator owners make the mistake by trying to save a couple of dollars by skipping this important step, which can create many issues if during the facilities audit, for example, mistakes are identified by the auditor, which could have easily been corrected during the design phase. This could be, in some cases, actually very costly mistakes. So our advice is always don't skip this important step. The next certification level is the constructed facility certification. As the name indicates, this is applied for the data center facility and is applicable to either data centers that have just been constructed, but is also very often applied to data centers which are already in operation. The auditor will now not only just review the data center design, but it will also physically inspect all parts of the data center under scope. The final one, the third option for certification, is the TIA-942 ready. This certification is applicable to products such as, for example, modular or prefab data centers, the likes of container-based data centers, data center pods, and even self-contained racks. So the idea is that once a product is TIA-942 ready certified, that the customers who are using those products can be assured that once the product is placed in the appropriate environment, that the overall data center setup will meet the requirements of the standard. On this slide here, you'll see some examples of the indicia which data center operator owners typically use as a step to prove that their data center is meeting the quality and conformance to TIA-942. There are also, of course, certificates which provides more details, such as the rating levels of the various aspects of the data center, as well as things like the issue date and the expiration date of the data center certification and other details. Talking about expiration date, certification for life is obviously not appropriate. That is why TIA is adopting the ISO standard for certification maintenance. Those of you familiar with ISO certification like 9000 or 27001 know that the certification has to be appropriately being maintained in order to guarantee the quality it's representing. So this chart shows you the full cycle where we have the certificate award date. The following year, a surveillance audit will be conducted, which is kind of a subset of the original audit. Year 2, another surveillance audit, and then in the third year, we will conduct a recertification audit. The whole aim is, of course, to ensure that any potential changes that have happened to the data center infrastructure, and that could be based on the facility itself, or maybe even loading factors within the data center, that they will not impact the original rating for which the certificate was awarded. This is, of course, very important to make sure that there is a continuous guarantee for quality of the data center and therefore gain the trust of customers actually using this particular data center. So what is the value of certification? Well, there are many reasons, but we list just a few of them. First of all, it allows you to give a clear availability expectation. We all know that customers, and especially our boss, always expect 100% availability. However, as explained, if you have a rated 1 or rated 2 data center, then this is of course impossible, and therefore expectations of the customers need to be correctly set and managed. The overall quality is a very important aspect of data center certification under TIA, as well as the risk reduction and mitigation management. Getting your data center certified will also help you to manage vendors. Ask yourself, how many data centers have you actually built in your life, and therefore how much risk is there that you might have potentially not understood certain risk factors. Even a simple single breaker or a valve in the wrong position could literally kill your ability to be, for example, concurrence maintainable and meeting the rated 3 requirements. So having an external auditor reviewing your data center and interacting with your vendors will ensure that you have that extra level of guarantee, which helps to make you sleep peaceful at night knowing that everything is in good shape. And finally, of course, trust. Let's face it, as a data center operator owner, we are in the trust business as our customers, whether they are internal or external, place their IT environment in our data center, trusting us that it will meet their availability expectation and that it will be well protected from a safety and security point of view.
We've seen some great perspectives today from Jonathan and Edward, and my perspective is a little different. I'm not a certifier. I'm not anyone who's implementing the standard as a consultant, I'm ground level. I'm the operator of the data center, or in my case, more specifically, in my role, I'm the interface between auditors and the organization that I work for, which is Iron Mountain Data Centers. There's a lot of standards out there that are applicable to data center or appropriate for data centers. And in this list, you'll kind of see some of these do cross over a bit, but there are regulatory compliance standards, frameworks, risk management methodologies that give breadth and depth. However, few are explicitly prescriptive about technical details, such as, TIA-942 brings to the table. Most standards aim to mitigate overall risk at a high level or demonstrate that a set of requirements are simply in place or evaluating the effectiveness of a control rather than being technical. So some of the things that we'll see in the industry, especially in co-location, which is the world that I come from, where, it's not a proprietary data center. It's actually, for example, the co-location data center would have a whole host of different providers within it in their own space. So everyone from the banking industry to healthcare to payment card processors and gaming providers, streaming services, they're all in these co-location data centers. So you'll see regulatory and information security assurance standards like ISAE 3402 associated with SOC, PCI DSS for payment card industry, SSA 18, which is the kind of Americanized North American version of that attestation report. And another regulatory one is HIPAA for the U.S. around regulatory compliance. And then also management systems. So Jonathan and Edward both touched on energy efficiency as part of the TIA standard. ISO 50001 is all about energy management, 14001 about environmental management, 22301 for business continuity and resiliency, and ISO 45001 for health and safety. So those management systems aim to give a holistic approach to how you take care of those respective disciplines in your environment. And, of course, with ours, it's data centers. And then there's best practices and frameworks, which sometimes, cross back over to regulatory, like ISO 27000, that whole series, whether it's 27001 as the certification or the risk management framework of 27005. NIST has a whole host of risk management frameworks and best practices for the United States. COBIT as a risk framework or IT best practice. And then, of course, ITIL, which a lot of us have seen in the IT service management world. And where all these things bring different aspects to the table of how you can certify your data center or manage risk in a data center, none of them are very specific in the way that they talk to technical specifications. So one may ask the question, why is that important to data center customers or folks who rely on data center availability? Because as Jonathan and Edward both kind of explained, whether you have customers relying on your uptime or someone else relying on you being, up all the time, going beyond a traditional audit or assessment, I think in my world, and as I see the industry developing now, is critical. Incorporating something like TIA-942 as a technical standard in audit can give a lot of positive reassurance behind an existing management system or framework, because it speaks to the technical details of managing risk at the data center operator level. And for me as an auditor, an information systems auditor and information security manager perspective, it demonstrates to me when I see other folks having it that risk management aspects have been evaluated, are in place, more so at a technical level. So you may have an overarching energy management system, or you may have an overarching information security management system that takes maintenance and cabling and other things into consideration, fire and life safety. But the TIA-942 standard really drills down to that technical perspective, making sure that things are in line from a holistic risk management lens. And that gives a lot of reassurance to customers. And then testing specific items that are assessed as in place, like SOC or ISO would. These are expanded upon with reviews of how systems actually work within the TIA-942 standard and through the audit process. And that in-depth auditing and that in-depth assessment really carries a lot of weight with co-location customers. I can assess that, test that myself. Right now, I'm actually going through an assessment with one of our customers in a few locations, and it's important to our customers and everyone downstream knowing that availability, integrity of the services there. And then, of course, lastly, for this slide, rating level outcomes as described earlier, Edward really touched on these great. The rating level outcomes are easily communicated and understood. And that's what's really important for me, because a lot of folks will ask questions about the rating and what rating 1, rating 2, et cetera means. And when we can describe that and then also describe how the technical standard is important to them, it makes the job a lot easier. So it's something that we're certainly considering and looking into. And I think co-location as a whole, it really needs something like TIA-942, because we see a lot of the basic standards in the ISO frameworks, but it doesn't really go to the technical prowess that TIA brings to the table. And a lot of it's really about transparency. So when we're looking at things from a technical perspective, architecture, risk, fire safety, physical security, site location, electrical, mechanical, and telecommunications being assessed is what's great about this. And I don't want to repeat too much of what Edward said earlier, but that really carries a lot of weight in a co-location environment with my customers. When we talk to them about standards, the standards we're talking about are great, high level, and giving an overview of what we do. But being able to take that technical perspective and explain it to the customer and explain this is why we are certified and this is why we went through the assessment and spent the time, is really valuable. So again, the rating system, when we communicate this to customers, it's something that demonstrates resiliency that's not shown in other audit frameworks and assessments. And for an operator, it's a common question, if not one of the most common questions that I get about being concurrently maintainable, a rating 3, or fault tolerant, which is something that we're seeing more and more. So there's not, fault tolerant it's not ubiquitous. It's not like concurrently maintainable. There aren't as many sites that are able to say they're fault tolerant and have an audit and an assessment backing that. But we're starting to see that question come up, and having the standard being able to report and, show that reliability is really valuable again. So with that said, there are limited ways to demonstrate this effectively. So having that third-party TIA-942 standard in place, having it verified by an assessment body, it really enables organizations to report on their reliability, unlike just saying, oh, we have ISO 27001 in place, so you can ensure that we have backups and we're doing what we say we're doing. Even if a third party is looking at it, it's still not looking at the technical aspect of it, right? They're not looking at the technical diagrams, the drawings, the details. They're looking at if a management system is in place. Now, certainly you can drill down your systems to be that in-depth, but to be brutally honest, a lot of assessment bodies that are doing data center verification of 27001 and the ISO standards, those folks are auditors by trade, looking at the ISO frameworks in accordance with the ISO auditing guidelines. TIA-942 is so much different and valuable in the fact that, for me as an operator to say that the technical details have been, taken care of. So with that said, it's another great value proposition, and rating 3 has been table stakes for years now. So a lot of large multinationals are asking the questions about rating 3, but fault tolerance certainly on the table for the future. And one of the things I want to touch on just lastly with this is, what are the benefits for data center operators? So capturing safety, business continuity, security, and energy best practices as parts of the TIA-942 standard are great, mainly because you could have a specific management system or framework implemented, like business continuity for 22301, health and safety under ISO 45001, which is formerly known as the British standard 18001, or energy management. And those are great. They're solely focused on those disciplines. But what's great and evolving about TIA-942 is that it is that all-encompassing kind of framework and standard, like Edward was mentioning, where it includes key aspects of those categories specific to how data centers operate. ISO standards are agnostic. It doesn't care what industry you're in. They're meant to be globally applicable and agnostic of whatever industry or sector that you're in. And you can certainly tailor it. But TIA-942 is carved out specifically for the things that operators in the data center space care about. So this can set a basis. So let's say you don't have ISO 50001 or ISO 22301. Having TIA-942 as an interest point could set a basis for organizations seeking certification, or get them more interested in the things that their customers are asking about and caring about. And then lastly, certainly not in as much detail as Jonathan hit on earlier, but the telecommunications cabling and topology specifications within the standard are really great for showing attention to detail, best practices, and competence of adequate telecommunications topology and cabling implementation, which is critical and key for availability in the data center environment. So this empowers us to show our customers that we're reducing risk by ensuring that entrance rooms, computer rooms, racks, main distribution areas, cable trays, all these things are employing the best practices that should be in place in order to mitigate risk in the data center environment.
But we have a few questions already. So I think the first one would be for you, Jonathan. Does the cabling redundancy require a different pathways or just a different routes in the same pathway?
For the rated 3, we don't require different pathways, but we recommend it. And for the rated 4, we also don't require it, but recommend that because you have different distributors for the rated 4, you really should have different pathways for the routes, but again, don't require it because in some topologies for the data center, particularly where you only have IOs in certain places, it may not be possible for them to, for the cables to follow completely different routes. But we recommend that they be different.
Okay. I have one for you, Edward. Does EPI certify data centers that it designed? So basically, does EPI certify a data center that EPI designed?
No, we don't, because that will be a clear conflict of interest under the ISO rules. So we never get involved with any data center that we have been involved in from a consulting/design type of perspective. So that's totally separated.
Another one for you, Jonathan. Is there any recommendation of having patch panel to connect servers to switch within the same cabinet, or can they be connected directly with patch cords?
Actually, in the TI standard, we have some guidelines regarding what we call direct attach cabling. So we permit direct attach cabling between equipment in the equipment distribution area or the server cabinet area, within a cabinet, and to an adjacent cabinet. So you would typically have a top of rack switch at the top of the cabinet or maybe in the adjacent cabinet, and you're allowed to run a cable directly to that. And that might be not only just structured type cable, the patch cords that we use, category 668 type cables, but they also might not be the common cables. They might be something like an AOC cable or a DAC cable, which are outside the scope of our standard. And then within a distributor, like the main distributor or the horizontal distributor, which might consist of a large number of cabinets, you're allowed to do direct attach cabling within that distributor, though we prefer it to be within a row of cabinets. So if your main distributor is very large, it consists of many rows, we would recommend that you install patch panels between the rows for that.
I think I have another one for you, Edward. Is there a time limit on the design certification?
Yes, there is. There is an initial time limit of 1 year. However, that is extendable in case that the design is still ongoing or the construction has not finalized yet. Then it can be extended with another year or even another year after that. Once the data center goes in operations, then it is expected that the customer moves forward with the facility certification.
I think we have another one for you, Jonathan. Can you please summarize what will be included in the Edge Data Center addendum? Will it include information on distribution areas, cabling recommendations, rack cabinet recommendations, etc.?
Right, yeah. Those subjects are covered, and I actually brought up a copy of the document that's currently being balloted. So why don't I go over the headings for the Edge Data Center addendum, and that would answer your question. So there's the scope, the modifications to the TI-942 standard, then going into Annex G, which is the normative section regarding the additions to TI-942, regarding edge data centers. So there's sections on edge data center design considerations, including things like sealing and anchoring enclosures, site location, anchoring equipment, and then there's a section on risk and hazards, a section on ventilation and cooling, one on energy efficiency for edge data centers, another one on monitoring, one on security, one on cabling pathways, a section on edge data center administration, another one on edge data center electrical, one on lighting, fire protection, water infiltration, and then we have another annex in a TI-942 that we'll be adding regarding the rating of edge data centers. And there's a whole set of tables similar to what we did in TI-942 for standard data centers, but for edge data centers.
Jim, I think we have a question for you. Is there any relation on risk mitigation and being certified?
I think there's a correlation. In my perspective, I would say that once you're certified, you've demonstrated that you've reduced some risk, of course, because you've implemented best practices. Of course, risk mitigation, when we think about it, you're evaluating and prioritizing your risks. So holistically in a data center, when you implement this standard and you're audited on it, you're bringing the risk level down by doing those best practices and being in alignment with the standard. So it is a risk mitigation method, but of course there are frameworks that are overarching that would address other parts of your business that, aren't addressed in TIA-942. But as far as availability and uptime goes, it's always important to remember that, this is a stepping stone and just a nice complement when we talk about mitigating risk in a data center environment.
I think this one's for Edward. Is it a given that TIA certification leads to compliance with other standards organization, or is it a standalone?
Well, there are obviously many standards available. So there are certain aspects. For example, if you look at, say, fire safety, TA references other fire safety standards like the NFPA 75, etc. But obviously, there are so many other standards like building codes that need to be complied to. So you cannot say, once I've done TIA-942, I can get rid of all the other compliance and other audits because that is not correct. So you still have to go for the individual areas of specialization like the building codes, electrical standards, etc., in order to see compliance for that particular aspect.
Maybe that's something you can answer, Edward. Can we use TIA-942 to certify edge data center?
Well, yes and no. We have the TIA-942 ready, so that is aimed at a modular style type of data center. It's not really aimed at edge in itself, and that's why TA had the initiative to develop the edge addendum, which will be released to the TIA-942. So that one, once released, will be the most appropriate one to apply to that environment. In the meantime, people could, of course, opt for the 942 ready as such.
Yeah, if it's not installed yet, I think the 942 ready is probably good. If it's installed, we can always use the current TIA-942, but it's going to be easier once we have the addendum ready.
Correct.
Good. Is there a plan to make TIA-942 an ISO standard? I don't know if, Jonathan, you want to take a shot at this one.
Yeah, actually, I also serve on the U.S. TAG that for the ISO IEC standards, and the ISO IEC standards are a different set of standards than the TIA standards. So almost everybody from the U.S. that attends the ISO IEC JTC1, SC25, Working Group 3, which are the telecommunications cabling standards meetings that develop the data center cabling standards and a lot of other cabling standards were from TIA, but we provide input to the international standards, but TI-942 is a separate standard from the ISO IEC standards. And to be honest, it's one country, one vote. So the US, Mexico, and Canada, which is all of North America, has the same number of votes as Norway, Sweden, and Denmark. And then, of course, Europe has many more countries than we do. So the standards tend to look more like the European standards, the ISO standards, because there are more country votes from Europe than there are from Asia and the Americas combined. So we provide input. So it's essentially we provide input, but they're really separate standards.
I think this could be one for you, Edward. Is there a path for an already rated 3 data center to become a rated 4?
Yeah, in principle there is. Obviously there are some potential changes that the data center operator owner need to consider. Most of the time what we find that in a rated 3 data center, most of them are already compliant to, for example, having multiple active paths, which is a requirement for the rated 4. But in rated 4, there is a more tricky statement, so to speak, that says that the data center kind of like need to be autonomous, i.e. you must be able to automatically detect a fault, isolate it automatically, and continue operation automatically. That's the whole idea behind being fault tolerant. And that requires, quite a bit of changes compared to a rated 3 data center. So electrical typically there, telecommunication typically there. On the chiller installation, that is typically where most data centers are, having to do quite a bit of work to become rated 4, as well as making sure that in rated 4 there is an additional requirement for fully separation physically, compartmentalization between the A and the B, where in rated 3 some areas like electrical are still allowed to be combined because it's only required to be maintainable. So it is possible, but it varies beside how easy or how difficult it might be.
And maybe Jonathan, is there any have you seen that before in your practice?
I think as Edward mentioned, it's possible, but you'd have to add redundant distributors, for example, on the telecommunications side. So you'd have to add things to the infrastructure to make that work out. And considering if the data center is already running, that might be really, really messy. It might be easier, really, just starting from scratch rather than trying to retrofit a rated 3 data center.
Yeah, I could only imagine if someone asked, from an operator's perspective, if someone asked us to go from a rating 3 to a rating 4, the undertaking and adding the infrastructure may outweigh the cost of just saying, let's start over and build one purpose-built to be fault tolerant. I think that question might come up because the risk for interruption and all the construction to just get the infrastructure in place might be too arduous.
That's a very good point. Which organizations are authorized to certify the TIA-942 standard? Currently, we're in the process of defining all of those criteria. We're revamping the overall process. We have partners that are currently doing TIA certification. They're advertised on our websites. So if you look at the TIAonline.org, you can find in this auditing section, you're going to find who the current partners are.
That's TIA-942.org, no spaces, breaks, or dashes. Is that right?
Yeah, you can use the TIA-942.org, or you can go straight to TIAonline.org as well. They both have the same information. How to make the data center compatible with 5G, and what type of basic change are required? Is it something you've encountered so far?
Well, I think when you talk about data centers and 5G, the first thing you have to think of is obviously edge, which Jonathan's talked a little bit about already in its relation to TIA-942. But 5G is inherently affecting the structure of how data centers operate because just the nature of 5G at its core, the whole idea, the whole concept is low latency application and network architecture that bring faster, more robust, bringing the core closer to the end, et cetera, right? So when we think about that in a big co-location data center like the ones that I operate and we host for our customers, that's really, in my opinion, not what's really bringing 5G to the table. The edge is going to really dictate a lot of how 5G impacts our day-to-day. So when we think about 5G, I would say think of the edge, think of where the edge needs to be, whether it's in city centers where large data centers aren't available, because typically you're not sticking a large, 40, 50 megawatt co-location data center in the middle of a giant city. It's going to be on the outskirts. So are your edge data centers for the 5G deployments going to be in the middle of a large city? Are they going to be in rural areas? Where are these things going to be? What's the application? But I think it all depends on the edge and where the edge is going and how fast, reliable, and secure the edge is going to be. Because reliability may not be as important with the edge, depending, but security and largely just the integrity of the whole deployment is going to be very important.
Good, thanks. What are the advantages of TIA-942 standard to an operator that serves only its critical load? I think this one, Jim, can you answer this one?
Yeah, so that's, if I'm reading the question right, this is talking about co-location. So we, as for my instance at Iron Mountain Data Centers, our customers make up our IT load, right? So our critical load for the whole building is the total facility, and we realistically don't control what our customers do. They move in, they're a partner and a tenant, and if they want 5 megawatts of the data center, they take 5 megawatts and they do their thing. So the advantage of how the TIA-942 implementation process is for a co-location, it's still looking at all the same aspects, right? You're still looking at fire safety, site selection, architecture. You're looking at how the MDAs, IDAs, and all the topology is laid out. You're still looking at the cross connects and cable runs. So there's still a lot of advantage, right? Even if you're not controlling the IT load in your facility, and you're not going down to the rack level, everything up until you get to that customer's suite or to their cage is considered. And I think that's what really sets TIA-942 apart, is because it does look at that larger approach for the data center site. But then beyond that, if you're a customer within a co-location data center, you can also have that assessment done for the space that you reside in. This is actually an assessment I'm going through right now with a few of our customers. The site's not being evaluated as a whole, but their space, whether it's 4 or 5 or 6 megawatt, is being assessed. So there's advantages on both sides of it. If you're a co-location operator, and I say this totally independent and objective from my position, but if you're a co-location operator that has customers that want the standard, that want the assessment, it's not out of the question. And then, of course, if you're operating a big data center, it's also an option. You can get that entire facility looked at as well.
How much emphasis is given to the 5 stages of the commissioning process to the ICT structured cabling system? Anybody wants to take this one?
Yeah, in general, if you look at the commissioning process, because it applies to the facility normally, of course, there are individual commissioning processes, for example, for the network infrastructure, which is typically done by the installers, where they do the traditional testing of the fiber and the other connectivity over copper. And those reports are normally evaluated during an audit, where obviously the audit itself is non-intrusive. So when we go in, we're not pulling cables, we're not pressing buttons, etc. So we would look at, for example, has the data center equipment been properly tested and commissioned? The testing reports and commissioning reports will be reviewed to make sure that everything is done appropriately, and that includes, for example, also the network infrastructure. The IT itself is out of scope for TIA, so we would not looking at, say, servers and storage and all those parts that is out of the scope.
What's the recommendation about interconnection between equipment through fiber or UTP patch cords? Jonathan, I think,
okay.
Can you answer this one?
Sure. That's actually that direct attached cabling issue that we discussed. So you can directly attach equipment in data centers. If they're in the server area or the equipment distribution area, you're allowed to do that. Directly attach equipment with UTP, fiber, DAC cables, AOC cables, or other peripheral type cabling like SCSI cables. If they're in adjacent cabinets, And if you want to go further than that, I suppose you could, but we recommend that you limit that to the same cabinet or an adjacent cabinet. And then, as I mentioned before, in your distributors, like your main distribution area or horizontal distribution area, you're allowed to patch between equipment within the distributor, but we recommend that you go through a patch panel if you have to cross them.
This is all the time we had today. The additional questions, we'll answer them by email. We'll make sure we get all the questions answered. So this is all the time we had. I would like to extend a big thank you to all our guest speakers for their time and sharing their expertise today.